Hi everyone, my name is Chan Yushen. I am from University Tun Hussein Malaysia, UTHM. My matrix number is AA200602. These are my group members, Yakesh Santiran, Kailasha Rao, Chan Yushen, me myself, and Lim Kian An. Today, we are going to discuss about the application of electromagnetic waves for far-field power transmission. It is called far field because the power is transmitted through a long distance without any wire connected. Nowadays, we can see that our Earth has become sick and worse. Air pollution in some big and developed countries has become more serious. Based on the statistic of the World Air Quality Index AQI, Malaysia is at the 48th place in the ranking. One of the factors that causes the air polluted is the combustion of gasoline and petroleum in the automobile, such as the aeroplanes, the cars, and the motorcycle. Scientists and engineers all around the world are working hard and trying their best to stop the pollution from being more serious. They had discovered and invented the far-field power transmission technology using electromagnetic wave. If we can apply this technology, the uses of gasoline and petroleum can be reduced. Indirectly, it makes the environment a better place with fresh air and clean air. Not only that, using far-field power transmission technology able to increase the mobility, convenience, and safety of an electronic device for all users.
Hello everyone, my name is Lim Kian An, and today I am going to present about the introduction to the inductive power transfer, which also known as wireless power transfer (WPT). The wireless power transfer can be defined as a process of transmitting an energy from a power source to the load without using any electrical wire or conductor. So you guys might be thinking how the power will be transferred without using the electric wire. So here is the answer. It will be transferred by the electromagnetic wave, which can travel through the air gap from the power source to the load and across the medium. There are two types of wireless power transmission, which the first one is the near field wireless power transmission and the second one is the far field wireless power transmission, which is the one that I'm going to talk about today. So unlike the near field wireless power transmission, the electromagnetic wave will travel through multiple kilometers of distance before reaching the antenna of the receiver in far field power transmission. Because of that, there are two types of electromagnetic wave that commonly used for the far field wireless power transmission, which is the microwave and the visible light from laser. There are some of the examples for the application of the far field power transmission, which includes the energy transmission from the orbiting solar power satellites to the Earth and the wireless power drone. After that, let's take a look at the advantage and disadvantage of the far field power transmission. As we can see here, there are few of pros and cons for the far field power transmission. For the first one is will be efficient. The next is low maintenance costs. The third advantage will be do not require grids and substation, since it is wireless power transmission. And the last advantage will be easy, simple, and farther than the near field power transmission. So next to the disadvantage, the first one is radiative and hazardous, especially the visible light from the laser, and the second contrast is high initial cost, especially building the transmitter and the receiver antennas. The third is require direct line of sight, and the last one, there will be some difficulty to narrow the beam because it is far field power transmission, so it will be difficult to make the beam or the electromagnetic wave narrower. After that, I will talk about the system architecture for the far field power transmission. So here is the block diagram for the simple concept of far field power transmission. So it starts with the AC or DC power supply, the VS here. So the power supply provides energy or power electrical which flow into the energy converting circuit. So the energy will be converted into electromagnetic wave and will be sent out by the transmitter antennas in electromagnetic wave form. So the electromagnetic wave will travel through the distance across the air gap and until received by the receiver antenna. After the antenna of the receiver receiving the electromagnetic wave, and the wave will be turned back into energy by the energy converting circuit again before the power is applied to the load. So here is a simple concept how the far field power transmission works. So that's all for me. Thank you.
Hi, my name is Kailash Rao and I did research about resonant pulse related work for the topic application of electromagnetic waves for far field power transfer. Okay, so far field power transfer, what I understand from this research is, from the past research, a lot of experiment has been done. So the first trial for this microwave, for this far field power transmission was in 1903. What they use is a microwave power transmission. Okay, the first model was an air-shaped motor of 0.1 horsepower is operated by transmitting power through space from a distance of at least 30 meters or 100 feet. Okay, after a few years, a man known as Brown published the first proposal paper of microwave energy for power transmission. In 1964, the same man revealed his microwave powered model helicopter. The helicopter receives all the power needed for flight from a microwave beam at 2.5 GHz from the range of 2.4 to 2.5 GHz frequency band. The frequency band is reserved 101 for industrial, science and medical, which is known as ISM. Nowadays, those helicopters are toys for kids, the radio control ones. So that's the origin. Okay, this method are applied in radio control helicopters and so on, drones. Later in 1975, experiments of power transmission without wires in the range of 10 kilowatts have been done at Goldstone in California and performed at Grand Basin on an Reunion Island in 1997. In Japan, the world's first microwave power transmission in the ionosphere, called the Microwave Ionosphere Non-Linear Interaction Experiment (MINIX). Experiment was demonstrated. It was in the year 1983. Reported that in 1987, the world's first fuel-free airplane powered by microwave energy from ground at Canada. So system used is called as SHARP, Stationary High Altitude Relay Platform. So then after a long time, Dryden Flight Research Center of NASA demonstrated a laser powered model airplane indoors in 2003. Okay. After that, in 2004, Japan suggested a wireless charging of electric motor vehicles by microwave power transmission. Then in 2007, Consumer Electronics Show, a new company known as PowerCast, introduced a wireless power transfer technology using radio frequency energy. In the same year, a physics research group led by Prof. Marin Solesik demonstrated wireless powering of a 60-watt light bulb with 40% efficiency at a 2-meter range using 60 centimeter diameter coils at the Massachusetts Institute of Technology. Okay, a year later, Intel, the one that makes computer chips, Intel, remake the MIT group's experiment by wirelessly powering a light bulb with 75% efficiency at a shorter distance. Higher frequency means higher power. That's one of the reasons why we have more frequencies. Okay, with the help of past related work, research or work, today we have technology developed using wireless power transfer such as UAV, unmanned aerial combat, that were used for army purpose. The one the drone will be flying outside but controlled someone in the control room. You don't need to be there to fly, which is risk-free. So then now we have drones and so much. So that's how this past related work help us in building a lot of new technology today. Thank you.
Hello everyone, my name is Yaki Sandiran and my matrix ID is AA201306. Today I am here to present about regarding my topic wireless power transfer on electromagnetic waves for far field power transmission. My friends and my teammates have discussed about the working principle and what does wireless power transfer mean and how does it work, all of that. Today I am here to conclude and to present about the references regarding this project. So, regarding wireless power transfer, this wireless power transfer is created by the almighty Nikola Tesla. Nikola Tesla is a very big scientist and he has done wonders to make this world a better place. Wireless power transfer definitely has the very high potential in changing the current state of the world. It's a really mind-blowing technology and it can really change in how people live and use stuff. Far-field power transmission makes the world a better place by providing several helpful functions. For instance, it helps the military by acting as a radar. It can detect or find wherever people are hiding or where our enemies are hiding, like that. This application helps to save many lives from danger. The introduction of wireless power transfer will reduce humans' dependence towards non-renewable energy such as fossil fuels and other petroleum products, because non-renewable energies will be gone one day. So we should not be dependent on such energy. At this very moment, the scientists are working very hard on making far-field power transmission less radioactive, because radioactive can cause very major dangers to humans' health. Even though researchers are implying practicals due to limited knowledge due to this pandemic, they fail to reach to the lab to do their lab works. So this is why they are stalling the far-field transmission project. Wireless power transfer is a very futuristic technology and many people are very much mind blown by looking at the capabilities of this technology. That is all from the conclusion section. Next we'll fall to the references section. These are the references that me and my teammates get together throughout the whole project. We refer to journals, articles, people's project. We use that as our references in order to build and create our own project in a better and a new version. So these all the references that we used. There are some journals, there are some articles, there are some other people's projects, and that is all from me. Thank you. Good day.